Hi there, I'd like to talk to you about a project in my lab as part of the larger Glycan project called GNOme, the Glycan Naming and Subsumption Ontology. You can find GNOME at GNOME, G-N-O-M-E, .glyomics.org. This is work with Wenjin Zhang and myself in my lab. All right, so GNOME is a applet and ontology, as the name suggests, that provides you a way to find the Glycan structures you're interested in. While Glycan provides stable Glycan accessions at various levels of characterization, from structures to topologies to monosaccharide compositions, they're difficult to find because they're not organized with respect to this hierarchy of characterization. GNOME organizes all of these stable accessions so that you can browse them interactively by subsumption, so that you can code up automated subsumption reasoning algorithms. You can do text-based lookup and do all of this with these well-characterized and well-defined characterization levels. This is integrated with the Glycan website as what's called related glycans. You can see 3 different screenshots of the interactive app on this page. You can see the so-called composition selector or topology selector, sorry, which allows us to quickly select a monosaccharide composition of interest, identify the topology that is relevant to the glycan that we're interested in, and then navigate to the view down below, which allows us to see various different structures that are shown with respect to their relationship for subsumption. Less specific structures are shown on the left, and the arrows indicate structures that are more specific on the right. You can see that we can deal with undetermined glycans in specific, but in addition, we can start with a fully determined glycan and look at all of the different ways that we might relax the information that we know about that particular structure. One of the ways that we have to navigate in GNOME, which is not interactive, is by looking for specific semantic names. We've been populating semantic names into GNOME to make it easier to find the compositions you care about. So for example, if you have a bionic format composition, you can see an example right here. You can paste that into the find modality of the interactive applet and immediately jump to the set of topologies which are consistent with that composition. Notice that it correctly understands what a hexnac is as opposed to a glycnac or any of the other specific monosaccharides. The applet itself, for those of you who are informaticians and who are developing your own websites, the applet supports deep linking. So you can jump to a specific Glycan accession or even supply the button states, the values of the counts on each of these buttons as a way of jumping into a specific place within the app. Monosaccharide compositions are not ignored either. You can see that these can also be studied in the composition browser applet. A new feature that we have just added to the GNOME interactive website is the align methodology, which allows us to take a novel glycan specified using glycoct or work sequence and align it against all of the Glycan database. This is a web service that you can query directly as a web service or run as a Docker container locally, but the interactive applet takes care of that for you. If your novel glycan sequence aligns to be a known glycan, you jump straight to that known glycan. And you can see that example down below where this glycan in the middle here is known. But if it's not known, a pseudonode is created that is in between the subsumption relationships of the existing nodes, so that you can immediately see that your novel glycan is not in Glycan and how it relates to other glycans that are registered in Glycan, so you can find the one that you care about. This is also the structure that the infrastructure that we use for the Glycan image extractor that allows us to extract Glycan images out of Glycan structures out of Glycan images. Well, that's all my time. Thank you for your attention.